The theme for the day is graphing exponential functions. The first one we're going to do by picking values and plotting points, and then we're never going to do that ever again, because what's going to happen is we'll know the general overall shape of an exponential function, just like y equals x squared always is a parabola, y equals mx plus b, always a line. Exponential functions will always have this general shape. So this is the only time we're going to pick points. And then after that, we won't have to anymore. Let's see, I'm going to start with f of 0. Very good place to start. F of 0 is 3 to the 0 power, so I'm going to put that 0 in the exponent. 3 to the 0 power, well, anything to the 0 power is 1. So now I have a point at 0, 1. Next, let's just do 1. F of 1, that's 3 to the first power, also known as 3. So I have a point at 1, 3. And let's try f of 2. Well, that's 3 to the second power, 3 squared, which is 9. So I have 3 points. Let's go back to the left and pick some x values back to the left. Like, let's try x equals -1. Well, 3 to the -1 power, we know negative exponents move into the denominator. So that's actually 1 over 3, or 1/3. And let's do f of -2 for good measure. That's 3 to the -2 power, so that's 1 over 3 to the +2. 1 over 3 squared is 1/9. So we have 5 points. That's good. Let's draw this graph with those points and see what we have. So I have a point at 0, 1, right there. I have a point at 1, 3, right there. I have a point at 2, 9, 4, 5, 6, 7, 8, 9. It's not too bad. So there's the point 2, 9. And then I have some points coming back the other way, -1, and 1/3 is pretty close to the x-axis. -2 and 1/9 is even closer to the x-axis. If you think about it, if I pick more and more negative values for x, like x equals, say, -10, 1 over 3 to the 10th power is 1 over something very big, which is very close to 0, but not 0. As I go farther out to the left, I get values that are even closer to the 0, but still not actually 0. So I'm never going to get all the way down to 0. If I connect my dots, I'm going up on the right, closer and closer to the x-axis to the left. And there's a sketch of an exponential function. The line out to the left, we give a name to that. A line that a function gets closer and closer to, but never crosses as it goes on toward infinity. The name of that is, it's a horizontal asymptote, also a good name to call somebody if you need something that's not actually offensive, but it sounds like it might be. That's a horizontal asymptote. It's a line, so it has the equation of a horizontal line. Y equals, well, it's the x-axis, so it's y equals 0. Also, we're going to notice the point 0, 1. That came from 3 to the 0 power. Well, no matter what the base is, anything to the 0 power is 1. So that's going to be an important point on exponential graphs. My base was 3, which is more than 1. What if I have a fraction for a base? Say the function f of x equals 1/3 to the x instead of 3 to the x. Well, it doesn't look very nice. It needs parentheses. It's offending my mathematical sensibilities. I have no idea how the mouse jumped all the way down there. So 1/3 to the x. Oh, that's better. Okay. But let's think about that. 1/3 we set up above is 3 to the -1 power. So this is 3 to the -1 to the x. But we also know a rule of exponents that says if I have something to a power to another power, I can multiply the exponents together. So that is 3 to the, I can call it negative x. But 3 to the negative x, well, that's just like 3 to the x, except I have that negative there. We know what that does to a graph. That causes a horizontal reflection, a left to right reflection. So this graph, I don't have to find any new points. It's going to be a horizontal reflection of the one that I already have. Instead of going up to the right, it's going to go up to the left. Instead of having a horizontal asymptote out to the left, it's going to have a horizontal asymptote out to the right, like that. So the first one we did is going to be kind of our parent generic function for an exponential function where the base is more than 1, and the second one is going to be our generic exponential function for a base that's less than 1. Let's take a look at another one that has some bells and whistles added in here. Let's do f of x equals negative 2 to the x minus 3 plus 1. Almost everything but the kitchen sink in there. We are not going to plot points. Instead, what we're going to do is we're going to look at what changes are in that function from the original one. One change is that the base is different. When the base is different, that acts like a vertical stretch or shrink. That's all that does. I'm not too concerned about that. I'm concerned with the rest of the stuff in here. Well, let's see. I have x minus 3 when I have a constant subtracted in with the x. The x's, poor little things, are backwards, so we're actually going to shift to the right by 3 units. I have a negative out in front of the function, which causes a reflection. Since it's out in front of the function and not inside with the x, that's a vertical reflection, an up to down reflection over the x-axis, however you like to think of that. And finally, probably the first thing you saw is that plus 1, but it's the last thing we're going to do. That's the whole thing is going to move up 1. Well, I want to look for the new location of my asymptote and my point. I'm also going to notice the base is 2, which is more than 1. Since the base is more than 1, it's going to look like my first version where I'm going up on the right with the asymptote to the left. Except we're going to reflect in a minute here. Then, where is that asymptote going to be? Well, let's see. If I take a horizontal asymptote and move it 3 to the right, nothing happens. Think about moving a horizontal line left to right. Not very exciting. If I reflect the line y equals 0 across line y equals 0 again, nothing happens. However, if I take a horizontal line and move it up 1, then something happens. So my new asymptote will be the old one moved up 1. So instead of y equals 0, now we're at y equals positive 1. Now we need to follow the point and find its new home. It starts at 0, 1 in my generic version of the function. Then I'm going to take it through those transformations that we listed up above. It's going to move 3 to the right. That affects the x-coordinate. Is going to change by positive 3, but not y. Then it's going to reflect across the x-axis. Well, that's an up to down reflection, so that's not going to affect the x-coordinate, but the y-coordinate will be same distance away on the opposite side of the axis, so negative 1 instead of positive 1. Finally, we're going to move the whole thing up 1. Well, that's a y change also, so my new point is at 3, and then I'll move up 1 from negative 1 to 0. We have the new home of the point. We have the new asymptote. We know the general shape. So let's draw this graph. I have a point at 3, 0, 2, 3. That's right there. I have a horizontal asymptote. Please do put these in the graph. When you draw these graphs, you can show it as a dotted line. Here's my horizontal asymptote. My original function over here went up to the right. I'm going to reflect that. So instead of going up to the right, I'm going to go down to the right. And then we had a horizontal asymptote to the left. We'll still have that, but we're coming up from underneath instead of down from above. So if we put that all together, there's my sketch of my exponential function. And we'll go and get the nice Desmos version. Here we go. So that was -2 to the x minus 3 plus 1. There's my x-intercept, or my new home on my point, 3, 0, and we can see the function going right along the line y equals 1.